In this example, we are going to see a complete example of text classification using various classifiers, and for that we are actually taking the US economic classic test. So we will actually economic text that we will see in the course of time. So here initially we are importing all the required libraries. So we need libraries to convert it into arrays and using data frames. So we are using NumPy, Pandas, and then we are also using these libraries MATLAB, Matplotlib, and Seaborn and Plotly.graph. So all those things for the visualizations. And here we are actually using this count vectorization, lemmatizer, etc. for pre-processing. And we are also using the string and regular expressions for visualization and tokenization and everything. And we are also using these algorithms like naive Bayes, multinomial, Gaussian, and logistic regression, linear support vector classifiers. All those things basically we are using as the models which are available in sklearn. And if you could see these libraries, these libraries are basically used for evaluation like accuracy score, then training, splitting. This is basically for training and splitting, and then confusion metrics, classification report, etc. are used for evaluation purposes. And we are also ignoring the timings by using this, that's all. And we are importing the data from within the Colab itself. Then analysis of data. So for analysis of the data, we will understand that we are using US economic news, and it has got almost 8,000 data, and we are also giving the encoding of the data and 15 columns. And here if you could see the relevance of your data. So relevance is basically nothing but it is one of the column. So how many data is actually there. So when you want to look at the data, your data will normally look like this. So in this data you have unit ID like trusted judgments, last written positive. So relevance is the relevance which we were actually talking about. So these are all the various 15. You have 15 columns. So in this particular, and 8,000 rows. Now you can also see about 8,000 like in the data relevance not sure. So it is almost 7111 right 9. So that means that if you plot it, the not sure sentiment is actually very higher, and sentiment which is S is actually very lesser. Okay, so we have to do a text processing. So what we will do is that we are actually doing a text processing with S is equal to 1 and no is equal to 0. Alright, so relevant is 1 and non-relevant is 0. And we are taking data of text comma relevance. So taking the text input and output variable as relevance. So you are taking the text and you want to identify whether it is you want to classify whether it is relevant or not relevant. That is what you are doing. So you are actually taking the first 1,000 data and and 2 labels. So that means that you want text and relevance, right? Text and relevance. So that is what you want. So you are actually taking the text and the relevance alone. So relevance is actually yes or no here. So it's kind of a labeled data here, right? So this is the major label. Okay, so this is the only things which you are actually taking. Then you are actually taking a count. So no is actually 0.82% and yes is actually 17%, and then you are actually plotting it. So when you plot it, you will be able to understand, clearly identify no is actually more and S is lesser, right? So this is your text and relevance. So now your data will look like this. So when you take the first data, it will give you the complete data how it is, and then you have to perform the text cleaning. So for that you require stop words and NLTK packages you have to download. And then comes the pre-processing parts of removing the stop words, and you are actually taking the stop words. So this we have actually seen multiple times, right? So we are actually tokenizing it and converting it into this thing, and then we are using WordNet, and then we use Spacey, and we are actually using this Encore Web Small is that model which we are using for. And then we are actually applying the lematizer. So when you apply the lematizer upon the data, and you're getting a cleaned data after all this. So when we look at it, this will be your cleaned data, and then again you are actually taking the text and applying the clean. So what happens is that here you will be getting the text relevance, but now it is actually the cleaned data. So now the major steps in your whole data is like split the data, okay, and then extract the features from the training, and you are actually doing it using the TF-IDF vectorizer, and you have to transform the data into a feature value, and then train the classifier, evaluate the classifier. These are the major steps which we are going to come. So when you look at the data, you are first actually applying the TF-IDF vectorizer, and you are actually vectorizing the data into an array, and then you are actually taking the relevance. Again, if you look at it, it's you have got 1000 data. So when you look at here, when you plot the data, you could see that 0 or 1, right? So 0 has got almost 757 data and 143, right? So when your train and the split training, you have got 800, and you are actually having testing of 200 data. So this is how, so 80-20, you are actually taking an 80-20 split for splitting your whole data. Now you are going to apply each and every classifier. So the first one is the naive-Bayes classifier. So in that you are actually using the Gaussian. This is one of the type of the naive-Bayes classifier. So you are applying the model, and say you are getting the accuracy score. So you will get an accuracy score of almost 99% and 76%. This is nothing but the training accuracy and the testing accuracy, okay. Now when you print your classification report, as always you will get all the details about non-relevant and relevant, and okay, and then comes the confusion matrix. So in the confusion matrix you are actually giving the y test and the predict test, and when you look at it, you will get your confusion matrix like this, and which actually talks about the false negatives and false positives, and actual negatives and actual positives. And then comes this part is actually the Matplotlib part, which will help you in Seaborn, which will help you in doing it. So when you look at it, it's almost like it's predicting, but it's predicting like half kind of. So there is some overlapping which is actually happening as part of the Gaussian. If you are using Gaussian NB, it is actually having some I mean, like it will not correctly predict everything. Then comes the naive-Bayes. So in the naive-Bayes itself we are using the multinomial. So in the multinomial we have already seen one example before. So you get almost like 75%, and you also plot the graph for it, so that it's easier for us to understand. And then comes the then you are actually predicting the I mean, like you are plotting it. Once you are plotting it, you could see that it is also almost like the Gaussian NB, but at some places you could see it even goes below. That means the prediction is not very perfect by using this, right? So it's because of the size of the feature vector is really big, and the Bayes algorithm works better for small number of features. Always understand, okay. Now comes the logistic regression. The logistic regression also you have to split the data into split and train and split the data, and then you are using the you are going to use the confusion matrix. So when you use the confusion matrix, you will see that how many actual positive, predicted negative. So all this information you will be able to understand from here. Then we are finally plotting it. Once we are finally plotting it, we are actually get to see that it's almost getting an good, I mean, like very nice percentage, because your AOC curve has increased from lower level to higher level. So if you have more area under the curve, that means that your classifier is able to predict it in a better way. I mean, like the classifier is able to predict relevant and non-relevant in a much concise and crisp manner. We have actually learned about. So in this video, we have actually learned about beautiful representation of comparison of different algorithms. So in decision tree, basically you have actually learned you're taking the decision tree classifier from a scale-on tree, and you're actually giving a seed value, you're fitting the machine, the model, and you're training and testing, and you're printing the accuracy. So when you look at the accuracy, you're almost getting an accuracy score of 0.7, and you are also printing the confusion matrix, and you could see how it works. And then comes ensembling. Ensembling, it's kind of, you can do the comparison between various models. So decision tree, logistic regression, and A/B is basically taken here, and you have a voting. So you will identify, or you will get the results for all the three, and you will do a voting, and whichever gets the highest accuracy, you will take that, right? So here, when you take all the three, you are getting different voting rates, but finally you identify that one of the as the top score, right? So this is how it is. We will work. So which one is the best is basically like, we have to try working on the relevant articles and the data set, and we need to do a lot of mix and matches, and we need to tune the parameters and everything and see which one actually works. Sometimes some algorithm might not work really well when we use it in the default format. We will have to tune the parameters, hyperparameters, in such a way that it is suitable for our system for getting better performance and results. So that's all about it. So if you have any questions or anything like that, you can always get back to me. Thank you so much.